This lesson is referred to the page 107 of the book. Electric variables. First of all, let's define what is a variable. A variable is something that can be quantified, measured, or counted. Some examples are the volume, measured in liters. The liters are the unit of measurement. Mass in kilograms. Kilograms is the unit of measurement, and for example, money in euros. Okay? We can measure different variables, parameters of electricity. They are related with the main components of a circuit. Each component introduces a parameter into the circuit. Let's see. Power source. The power source supplies the voltage the energy to the circuit. Also, the voltage, this variable, is called potential difference. Okay? The letter to refer the voltage is the capital V, and the unit of measurement is the volt, and the symbol of the volt is also a capital V. I will try to explain the concept of the voltage, okay? Imagine we know that the electrons are negative charges, okay? So they repel each other. Now imagine that inside a box, inside our battery, we store lots of them together. What is this? They will try to get out, no? They will try to escape because they repel each other. So imagine that the voltage of a circuit is, or are, electrons under pressure. Conductors. This variable is the current. The letter we use is the capital I, and the unit of measurement is the ampere, with the symbol is the capital letter A. Okay? We know that the current is the amount of electrons through a conductor. So, the concept of the current is the amount of electrons through a conductor per second, right? Or in a second. Now, load device. We know that load devices are responsible for converting this energy into another form of energy. The parameter that describes this phenomenon or this fact is the resistance. The resistance, we use the capital letter R, and the unit of measurement is the ohm, ¿vale? And the symbol of this unit is the omega Greek letter, this symbol. Okay, imagine that I have a cable. To explain this concept, imagine that I have a cable and I reduce the thickness of the cable. So it is an opposition, okay, to the flow of electrons, to the current. Is this, okay? It's like an opposition to the flow of electrons. The load devices consume the energy of the electrical energy, and they try to stop the current, okay? What they do is convert this energy, and what inside the circuit is a resistance, is an opposition to the movement of electrons, to the flow, okay? So opposition. There is a relationship between these parameters. On the left, we have the volt. The volt is the unit, okay? The voltage trying to moving the current, okay? The current is the green one. And when the current tries to pass through a load device, the load device makes a resistance to pass, ¿vale? The resistance tries to stop, okay? And the load device transforms this energy into another type of energy. Okay, so we can relate these three variables in a formula, okay? George Simon Ohm came up with the formula, with the equation. He found out how to relate these three variables. The voltage is the product between the current and the resistance in a circuit, okay? To remember this formula easier, we can use the triangle and if I want to remember, well, it's easier to remember. If I want to get the value of the voltage of a circuit, I put my finger on the variable that I want to calculate and I get the formula, okay? Current multiplied by the resistance. If I want to get the resistance, I get the voltage divided by the current. If I want to get the current, it's the voltage divided by the resistance. Let's practice this with the examples from the page 107. the examples is calculate the current flowing through the circuit, okay? The instructions to do this type of exercises are: first, I draw the electric diagram, okay? The electric diagram with the elements. Then, the elements and data, okay? Then I write the formula. It is asking me to calculate the current. So the current is the voltage divided by the resistance of the circuit. I calculate this. And the solution with the parameter and the units. Amps, okay? 0.02 amps. Now, 14, page 107. What voltage must the cell have to allow? I draw the diagram and I put my data and I calculate it. Two amps multiplied by 5 ohms is 10 volts. And the last one, what resistance should we use for a flow of 300 milliamps? I have to convert this, okay? The milliamps into amps. How? Dividing by 1000. Is the same if I tell you milligrams, okay? Or millimeters. Is a divisor of the unit of amps in this case, or the unit. And now I introduce in the formula, okay? $40 ohms, okay? So now you can complete the notebook of electricity that is uploaded on the web page. And the next lesson, I will upload the solutions of this notebook, okay? Before the exam of this.